Okay, so I am Soumodeep. Today I am going to give you a lecture on the topic of circles, and for a time constraint I am in the first day I am giving you 3 to 4 questions I will discuss, and on the next day, on my next video, I will come up with say minimum 7 to 8 questions. After that I will provide you the DPP of the chapter. Okay, till now I have discussed the chapters of straight lines, pair of straight lines and circles. I will provide the DPP. It will consist of 40 or 50 questions, and I will give you 1 week time to complete that. Okay, thank you. So let's begin. Okay, so let's start with today's first question. The question is, the common tangents to the circles x square plus y square plus 2x equal to 0 and x square plus y square minus 6x equal to 0 forms a triangle, which is it's questioned as the formed triangle by the tangents to these two circles will be equilateral, isosceles, right angled, or option D is none of these. So let us first check the condition of these two circles, that whether they are intersecting or just touching each other or are far apart from each other. So what's the theory behind that? So let the center of the first circle be C1, that is minus 1 comma 0, and center 2 of the circle, that is 3 comma 0. Okay, minus g comma minus f. So now let me find the distance between C1 and C2. Okay, so what will be 3 plus 1 whole square plus 0, so it will be 4. So now what is the radius of the first circle? Let me call it as R1, and the radius of the second circle as R2. So radius of the first circle will be 1, and radius of the second circle will be under root g square plus f square minus c. It is coming as 3 again. Okay, so now R1 plus R2 is equal to 4. Now see here, C1 C2 is equal to R1 plus R2. Can you see this? C1 C2, the distance between the centers of the two given circles is 4, and the sum of the radius is also 4. So can't we say that this diagram is correct? Let me call it this is as the first circle, and this somewhat this as the second circle. Sorry, this will be my second circle because it's the bigger one, and this is my first circle C1. Okay, so now if this is R2 and this is R1, so can't we say that R1 plus R2 is equal to C1 C2, and thereby the two circles are neither intersecting nor far apart, but they are just touching each other. So it can have 3 common tangents. The number 1 common tangent will be this one, and other 2 are this one, these 2. Okay, so let me call this as point P, and this point where the tangent is touching the first circle, let me call it as points T1 T2, and the points where these two circle tangents are touching the second circle as point T3 and T4, and let me call this the intersection point of these two tangents with the first tangent, that is the common tangent, is as all 3 actually are common tangents. The first common tangents as Q and R. So this point is Q and this point is R. Okay, so now let's play with some geometry over here. We know that from outside point, if we draw pair of tangents to a circle, then their distance is same, that is the length of the tangents are same, that is P T1 is equal to P T2 and P T3 is equal to P T4. That is P T1 is equal to PET2 and PET3 is equal to PET4. So from here we can write that T1 T3 is equal to T2 T4. Can we write this? Of course we can. If these two lengths are same and these two lengths are same, then can't we say that these two lengths are same? We can say. So from this we can also write that T1Q is equal to T2R. Of course we can say this because from the symmetry of the figure we can get this. So now let's come to this one. PT1, we can write this as PT1 plus T1Q plus PT1 plus T2R. I am just adding PT1 in both sides of this equation. Okay, so now what it's coming, PT1 plus T1Q is PQ and PT1 plus T2R, it's PR. So PQ is equal to PR. So in this triangle, in the question it was given that the common tangents to the circles this and this form a triangle. So this is the triangle. This is the only triangle that I can see the pair of tangents are forming. That is triangle PQR. And from here we have already got this relation that PQ is equal to PR. PQ is equal to PR. So the only option which can be correct is option B, that is the triangle is isosceles. Okay, so that this kind of question is actually very easy. You just have to check whether the two circles are intersecting or not and just draw the diagram carefully and do some geometrical calculations in your rough mind. You can't take so much time in this question, you have to be fast, and it's actually easy question. Okay, so now let's move on to the next question. So the next question is, it is given that the two circles x minus 1 square plus y minus 3 square equal to r square and this circle intersect in two distinct points. Then now this is different from the first question. In this question it's already mentioned that the two circles are intersecting at two distinct points. So the diagram can be like this. This is the first circle and this is the second circle, and there are two distinct points, points A and point B. So this is, let's say, the center of the first circle. This is the center of the second circle, that is C1 and C2. Here C1 is given as 1, 3 with radius R1 is equal to R, small r, and center 2 is given as 4, minus 1, and radius of the second circle we can find it as g square plus f square minus c. It's 16 plus 1 minus 8, that means 9, that means under root 9 is 3. Okay, so it's very clear. Now see one thing, there are some conditions. Okay, from the first sum we have learned that if C1 C2 is equal to R1 plus R2, that means the circle will be like this. They will just touch each other. C1 C2, the distance between the centers will be equal to the addition of their radiuses. Now in the second one we can say that C1 C2 is greater than R1 plus R2. That means the distance between the centers is greater than the sum of the radiuses. That means the circles will be far apart. Distance between the centers will be greater than R1 plus R2. In 3, C1 C2 is less than R1 plus R2. In this case the circles will intersect. Okay, the circles will intersect. Now under this one there are two cases. Okay, that is R1 minus R2. Okay, mod. If this value is less than C1 C2, then what will be the condition? Then the circle can, I'm drawing it over here, then the circle can lie inside another circle. Okay, can lie inside. Okay, am I clear? Because let me draw it clearly over here. Suppose this is the first circle and it has value r1, and this is my another circle having center over here, and this is r2. Okay, so can you say that r1 minus r2, that is this thing, this whole is r1 and this much is r2. If I cancel r2 from r1, the remaining portion will be this one. Okay, that is c1 c2. If this can be equal to or lesser than c1 c2, then one circle will lie inside the other. Okay, so now in this case I can take it as mod r1 minus r2 is less than c1 c2. Okay, because I'm telling you why. Because it's already been said that there will be two distinct points. Okay, this can also be these two circles can also lie as like this, where this will be the distance between c1 c2 and r1. This is r1 and this is r2. Okay, now if I cancel r2 from r1, that is r1 minus r2 mod I am taking is less than c1 c2. Okay, in that case it can partly cut, the two circles can partly cut, so that's why I am taking this condition over here. Okay, so what will be r1 minus r2? It will be mod r minus 3 is less than c1 c2. The distance between the centers will be what? Under root 4 minus 1 square plus of minus 1 minus 3 square, which is less than r1 plus r2. That means 3 plus r. So here mod of r minus 3 is less than under root 3 and 4, it will be 5 under root 3 plus r. Okay, so from here I can get that if in the first case I am taking this as r minus 3 is less than 5 less than 3 plus r. Okay, in this case what will happen? It will come as if I keep the minus 3 over here and plus 3. Okay, so it will come as, okay, let me take this first two. Okay, in this case it will be r is less than 8, and in this two it will come as r is greater than 2. So that means 2, r is greater than 2 but less than 8. Okay, it's the first option. And if in this case r is less than 3, then this mod will become 3 minus r and 5 3 plus r. So from this first two we will get that r is greater than 8, and in this case I will get r is greater than 2. So this is not in my option. Okay, r is greater than 2 is in my option, but this is a more prominent one from 2 to 8. Sorry. Okay, so this was a bit conceptual question, but a very nice question and important actually. This kind of questions are generally asked in WBJEE. Okay, so try to practice and solve these types of questions from different books. Now in the third question it is given that if the circle this bisects the circumference of circle this, then c plus d will be what? Now again it's given that one circle is bisecting the circumference of the other circle. So how can you draw the figure? So let this one be your first circle with center over here, and another circle, it will be like something this. will be the bigger one, like this. Okay, so this is my center 1 and this is my center 2. Okay, and this will be my common chord. Can you see that from the center line, from this diameter, I have drawn the two cutting points of the other circle, because it said that bisects the circumference. Bisects the circumference means this is one portion of the circumference and this is the other portion of the circumference of the first circle, and half of the circumference of this circle must lie within the bigger circle, so that I can say that the circumference is bisected. So in this case, what will be the common chord? Do you know how to find the common chord? If this one is the equation of one circle and this is the equation of the second circle, then equation of common chord, that is this line, this is the common chord. Equation of common chord is got by s1 minus s2 equal to 0. Okay, so in this case, how can I find that? Let me get that. X square plus y square plus 4x plus 22y plus c minus x square minus y square plus 2x minus 8y plus d equal to 0. X square y square getting cancelled. So what is left over? 6x plus 14y plus c plus d equal to 0. Okay, so this is just left over. Now what is my center 1? Center 1 of this circle is minus 2 comma minus 11, and center 2 is given as what? 1 comma minus 4. Okay, now what will be the equation? Actually the radius of the first circle will be R1 will be 125 minus c, and R2 will be 16 plus 1 17 plus d. Okay, now I don't know which circle is the bigger one. I don't know which circle is the bigger one. So let me take, since it's 125 minus c and here it is 17 plus d, so let me take that. Actually it's given in the question. I have drawn the figure actually in the opposite sense. Okay, so this will be c2, this will be c2 and this will be c1. Okay, the bigger circle will be c1. So just check over here. Okay, just interchange. Okay, because why I am changing this, in the question it was given that the circle this one bisects the circumference of circle this one. That means the circle with centered minus 2 comma minus 11 is bisecting the circumference of the circle this one. Okay, with center 1 comma minus 4. So this center, the circle whose circumference is getting bisected will have center minus 1 comma minus 4. So can we say that the equation of the common chord that I have got, it will pass through the center of this circle 1 comma minus 4? Yes, of course I can say. Then let me get it. In 6x, in place of x it will be 1 plus 14 into minus 4 plus c plus d equal to 0. Then c plus d will be equal to 14 into 4 minus 6. So 14 into 4 is 56 minus 6 is equal to 50. 50 will be the answer. Okay, option B is the correct answer. So there was nothing in this question. It was an easy one and again a very conceptual one. Okay, let's move on to the next question. Okay, in this question it's been said that a variable chord is drawn through origin to the circle x square plus y square minus 2x equal to 0. Then the locus of the center of the circle drawn on this chord as diameter is. So if this is my given circle and let this be a chord passing through origin to this given circle and pointing this points as AB, midpoint of this line segment AB is the center of the chord, and AB as diameter, there is another circle that is getting formed. I have to find the equation of this circle. So how can I find chord in terms of midpoint? T is equal to S1 for this first circle. I can find the equation of this chord, that is let me take the midpoint of this chord as of C as H comma K. Then it will be T will be Hx plus Yk minus A into X plus H, and S1 will be H square plus K square minus 2AH minus 2AH. So if I simplify, it will be Hx plus Yk minus Ax minus plus AH equal to H square plus K square. So this is my equation of the chord in terms of midpoint, where point H comma K is the midpoint of the chord. Now it's been said that it is passing through the origin. Now if I put x equal to 0 and y equal to 0, it will come as Ax. If I have to put x equal to 0 and y equal to 0, so these three terms will get cancelled and I will remain with H square plus K square is equal to AH. Now this is the locus of this circle, where if I put H as x and y as k as y, then I will get x square plus y square equal to Ax, where any point x comma y will lie on this circle. So can you see that it is the equation of a circle? This locus is coming as the form of equation of circle. So this will be the locus of the center of the circle drawn on the chord as diameter. So equation, the locus of this center is this one. Finally I am substituting this value of H as x and K as y to get the locus. So option B will be the right answer.